We want to determine if this series is absolutely convergent or conditionally convergent. So what we want to do is check for absolute convergence first, because absolute convergence implies convergence. So let's take the absolute value of this series. So we would have -1 to the power of n minus 1, and we're going to absolute value this. So this is obviously going to give us 1 over the square root of n there as the sequence in the series. And then this is the same as 1 over n to the power of 1/2. And then 1/2 is less than 1. So by the p series stuff, since p equals 1/2 and 1/2 is less than 1, then this diverges. That doesn't imply that this diverges. This implies that this is not absolutely convergent. It may still be conditionally convergent. So now we have to check with another test. So what other test could we use? What other test could we use on this to check if it's conditionally convergent, at least? So we could use the alternating series test, because we have b sub n and we have the alternating part. So whenever we have something like this, whenever we have something of this form, and b sub n is greater than or equal to 0 for all n. By the way, you could write for all like this, like an upside down A, for all n. Then you could use the alternating series test. What is the alternating series test? So the alternating series test has two conditions. The first one is that if you take the limit as n approaches infinity of b sub n, and that equals 0, and the second condition, that b sub n is decreasing, then you can say that it converges. We already eliminated absolute convergence, but it could still conditionally converge. Okay? So let's check. What is our b sub n? Our b sub n is just a portion without the alternating stuff, the stuff that causes it to alternate. So it would be 1 over the square root of n. Obviously, if we plug infinity into a denominator, that will be 0. So yes, it passes the first part. Is it decreasing? Yes, because we're going to plug in larger and larger numbers into a denominator. So it's going to be decreasing. So it converges. We already eliminated absolute convergence. So this conditionally converges.